Okay. So first one we'll see about IP address and MAC address, then IP address, IPv4, IPv6. Then I will tell about a few points in IPv4. Okay. So we'll see. First one is, what is an IP address? Guys, IP address is a logical address and MAC address is a physical address. So IP address is defined like this. It is uniquely identify a device in the network. What is the use of this IP address? It is to identify a device in the network. So I have put one diagram here. Okay. So you have a devices. Every device has an NIC to connect in the network. Every NIC has a dedicated MAC address. Okay. To communicate in the network, the device need an IP address. So we have to configure an IP address to the device. Okay. What is that IP address? Is nothing but our logical address. And it is not unique. It is uniquely identify a device. Like you have a name to identify. So who is the people are attended. So how we can take an attendance based on their identification, right? You both are having same names. So for example, Swati Arya and Swati Pal is there. Rahul, two Rahuls are there. So somewhere it is the surname or end name difference is there, right? So one batch I have two people with same name, Amit Kumar, Amit Kumar. So we can't do anything by put two names with one is cap letter, another one is small letters. Okay. So we'll see this kind of stuff, guys. You have a device to communicate in the network. Compulsory, there must be a IP address. Okay. Devices to communicate in the network, they need an IP address. All communications in the network by IP address only. All communications in the network by IP address only. Right? Not with the names, not with the MAC address. This IP address can be assigned to a device, either manually we can assign or we can get an IP address automatically. Automatically means from DHCP server. Okay. And IP addresses can also be changeable. We can change manually or you connected to a network and from DHCP server you will get a different IP address. Okay. Your IP address defines what is your logical network. What is your logical network? Of course, there are so many things about IP address, guys. Once we are into the IPv4 and then we'll see what is a logical address, what is network address, what is host address kind of stuff. Okay. So to communicate from one to another one, for example, A want to communicate it to B, or A want to communicate it to C. How they will communicate? A will send a packet to C with the C's IP address, or B want to send a packet to A with A's IP address. So compulsory to address and from address is required. So compulsory you should know the destination IP address. Okay. What is this logical addressing? So I will give you one small example, guys. Your batch is 22. Okay. You have a roll numbers, right? So you have a roll number like this. I given numbers only here, not as some roll number kind of some serial number I given. Think like this. I'm giving a roll number like this. 20 to represent your batch number. One represent identification of person. For example, Aman is 1. Anant is 2. Okay. So because of one addition, so then it is kept changeable. Anant is 2. Okay. But both are in the same batch, so this is not changing. Okay. So this is, for example, think like is a roll number. It means different roll numbers means each person identification, and this is their batch identification. For example, last batch I deal, that is 20th batch. 21 batch is missed. As another SAR is taken that one. Okay. So what is this meaning? It's a 20th batch and different roll number, different identification. So this is logically both are different batches. Both are different batches. And these are all in the 22 batch. These are all in the 20th batch. That it is a logical addressing, logical part. And of course, I will. That is example important to see other one. In this example, also given each one having an IP address from A to B communication at B. I'm trying to ping to BPC means B's IP address, destination IP address. An IP address is two versions are there currently. One is IPv4 version, another one is a IPv6 version. IPv4 is a 32-bit size in a binary. IPv6 is 128-bit. IPv4 represented in decimal format. So decimal numbers we are using here. Okay. So if you convert entire this into the binary, the total binary bits are 32-bit. Total one single IP address size is 32-bit. Next, IPv6 is a hexadecimal number. So then the numbering what we decimal numbers what we are using, hexadecimal numbers we are using in a IPv6. This is look like this one, and if you convert entirely into binary format, the total binary size is 128 binary bits. Okay, guys, this is small introduction to IPv address. It's a logical address, uniquely identified device in the network.
Hello, sir.
Yeah, tell me.
Yeah, can you please once explain that point? IP address can changeable manually automatically.
Yeah, okay, I will tell. Uniquely identified device in the network, and we are all communicating with an IP address. To communicate in the network, you need an IP address, and that is good. So, IP address can be changeable. Either you can change manually. So, we'll see that one. You can see pa.cpl. It opens directly network connections window. Okay, so I will go to something which is this one, some virtual adapter. If you change something, it is also no problem. So I check. I got an IP address from DHCP server because I have some DHCP server. From this DHCP server, I got an IP address. Okay, and if you see, this is the MAC address 005056C00010. I go to the properties. I want to change it to manual. IPv4 properties. So manually I'm changing. So I'm putting some 10.0.0.1, some IP address. Just for knowing, so how to do it. Okay, manual. I assigned it manually. See, it is DHCP enable no means this IP address assigned manually. DHCP means IP address assigned automatically. Okay, but MAC address is not changing. IP address can be changeable like a manually. If I don't like that one, or maybe it is not correct one, I want to change it manually again, so I will change it. For example, I will take here 172.16 and take. Okay. So if you look at this, I change my IP address. So IP address can be changeable. MAC address we cannot change. Okay. And dynamically changing. So I am going to this IPv4. Now I configured manually. I thought, so no. I want to get an IP address from DHCP server. Then what I have to do? Select obtain IP address automatically. So then I will get an IP address from DHCP server if it is there. Okay. So then again, see this. I got an IP address from DHCP server. This is my DHCP server. This is DHCP enabled means I got an IP address from DHCP server. Okay,
Yes, sir, got it.
got it? Very good. So that is how to get an IP address, either it is automatically or manually. I didn't take any screenshot. I think already we have screenshots. That there it is. Again, I will show you this. Next one is MAC address, guys. Already I told MAC address earlier, but again I'm telling, and because of IP address and MAC address, differences is very important. That's why I'm telling you again. Every device must have an NIC to connect in the network. Every NIC has a MAC address. And MAC address is also called as a physical address or a hardware address. This MAC address size is 48 bit. Actually, it is written in a hexadecimal format. This is an example MAC address, and if you convert this into the binary format, you will get a 48 binary bits. This MAC address is given by NIC. So when you are buying an NIC, or you have a built-in NIC in your mobile, or USB type of NIC it is, whatsoever it is, the manufacturer of that NIC is assigned this MAC address, which we cannot able to change. We can't able to change in MAC address. MAC addresses cannot be changeable. But there is a 2 points I've written here. So one is MAC spoofing is possible. MAC binding in Wi-Fi networks is possible. MAC spoofing is
Sir,
possible. Yeah,
so what is spoofing? Mark spoofing.
very good, very good. So usually for attacking purpose or security purpose, okay, either for a attacking purpose or securing purpose, people use some kind of applications to spoof their MAC address. Means duplicate MAC address. Means original MAC address is not changes, but while they are sending a packet or receiving a packet, they use a kind of MAC address here with some applications. Okay, it is useful for both the things, for attacking someone or maybe in for a security purpose also. Okay, so
Yes, sir.
duplicating MAC address. Very good. What is this MAC binding? MAC binding. Guys, we have a Wi-Fi router. Everybody knows this Wi-Fi router now, right? Wi-Fi router is there.
Yes, sir.
How to connect it to Wi-Fi router from your mobile or laptop? Open settings like this, right? You have to click here from laptop. In mobile phone, you have to go through this Wi-Fi symbol. Open it, search for your Wi-Fi name, and give username. Sorry, already name is there. Password you have to give. enter the password. And it will go to this Wi-Fi router and verifies your password. It is correct, and you will get connected. You will get connected, right? How you will connect it? Simple. Search in Wi-Fi network, then select a password. Very simple, right? If someone knows, for example, when I was in Pune, so one of my neighbor and as well as my owner asked my Wi-Fi password. So I take their mobile phone and configure into their mobile phone. So they can able to connect it to my Wi-Fi router. So one day I checked how many connections in my Wi-Fi router. Through Wi-Fi router interface, I checked from my system. More connections are there, means more than my connections. I have a laptop, I have a mobile phone, I have another mobile phone. So there is three, four, five, so six, seven. So totally more, not more than seven or maximum eight connections should be there. I have seen 10 to 11 connections in my router. Means they shared password to others. Okay. Some person knows my password. He tried to connect me. Understand? Person who suppose not to connect, so then they will connecting. Okay. So I want to stop him. I want to stop these unauthorized connections. Even though they know the password, I want to stop them to connect. What I will do? So I will verify these connections and I put this MAC address list. There's two things are there, guys, here. So understand. I collect the MAC address of authorized devices. Authorized devices means those devices should get a connectivity, mobile phones or laptops. So then I will put a list in my Wi-Fi router. MAC address, MAC address, MAC address. These MAC addresses are allowed to get connected. So when these devices are connecting, it will check the list. MAC address is there of this device. Allow connectivity. Again, this device is trying to connect. It will verify this BC MAC address with this list. It is there. Allow. A device is trying to connect. It check in the list of this device MAC address. If it is not there, no connectivity. Okay. So what is this MAC binding? Very simple. At in Wi-Fi router, you can simply tell do not give connectivity to this particular MAC address or allow only these MAC addresses, deny every other MAC address. Allow only these MAC addresses, deny other MAC addresses. So what happened? Only whenever the device is connected to my Wi-Fi router, it check the list. In the list, the MAC address is there, connected. Not there, not connected. So when device is communicating, so they will share the MAC address. This is one of the importance of MAC address also, guys. Okay. So this is a MAC address, guys. Again, differences. IP address can be changeable. MAC address cannot be changeable. IP address is logical address and MAC address is physical address. IP address assigned by manually or automatically from DHCP server. MAC address is assigned by manufacturer of that NIC only. IP address having two versions, IPv4 and IPv6. IPv4 is 32-bit and IPv6 is 128-bit. MAC address is 48-bit, no additional versions. Only MAC address is only one MAC address. It is universal, guys, universally unique. MAC address is universally unique. Only one MAC address in entire world. All communications through IP address only. MAC address is there in the communication, but not it is a main communication. Okay, while you are communicating from one device to another device, the MAC address is there. But MAC address is not a main part of communication. We are communicating means you are addressing to some device. We should address with the IP address only. Okay, that is the difference between IP address and MAC address. Understand, guys?
Yes, sir.
Yeah,
Yes,
this is
sir.
okay. Last batch people ask binary, octal, and hexadecimal numbers. That's why given like this. It is actually not required for you. If you don't know binary numbers, hexadecimal numbers, and all, I will give that information. No problem. Okay. Here we'll see the IPv4 and IPv6, small differences. Then we'll continue IPv4. Okay, IPv4 is 32-bit, IPv6 is 128-bit. IPv4 is 2 to the power of 32. So you go to the calculator. Okay, so IPv4 is 32-bit. So 2 to the power of, sorry, 2 to the power of 32. So this is the total size of number of IP addresses. Okay, so if you write an IP address from starting IP address to the last IP address, this is the total number of IP addresses from IPv4. IPv6 is 128-bit. 128 means 2 to the power of 128. See, it is a very big number. You can see 4.3 and very big number with a 10 to the power of 38. E plus 38 means 10 to the power of 38, 3.4. So that's why it is very big one. Okay, so IPv4 is 4.3 billion, around 4.3 billion IP addresses from IPv4. Okay, so the exact number is that one. So we can put a number on it. IPv6, we cannot write the full number. Okay, so that's we writing a 3.4 billion, billions of, it is undecillion. Okay, undecillion number, the meaning in it. 3.4 into 10 to the power of 38. Meaning is 34. Write 34 first and put a 37 zeros. First 34, then after 34 put a 30. Okay, so first 34 and put a 37 zeros. That is a very big number, right? So that is a IPv6, number of IPv6s we are getting. Okay, it's a very bigger one. IPv4 is a earlier, and till we are using IPv4. IPv6 is a new into the market. Okay, of course, some companies, some organizations, some private internet service providers, some internet service providers, and internally, and certain countries are using IPv6. But globally, 100% IPv6 we are not using. Not everything is updated to IPv6. Okay, still we are using IPv4 only. IPv4 is in the decimal format. IPv6 is hexadecimal numbers we are using. Example of IPv4, I written 192, 145, 78, 34 like that. So there is a dot is there, guys. It's not point, it is dot. 192 dot, 1645 dot, 78 dot, 34. IPv6, whereas IPv6, so it is written like this. It is colons are there and the numbers are in a hexa numbers. Even you see 2, 4, 3 kind of stuff, that is also hexa number only. So 2098 colon 56 AC colon 38 CB colon like that it is there. Okay. So then we will try to explain. Actually, typing is very easy. I copy pasted to save the time, but typing explanation is feels good. So coming to the IPv4 guys, IPv4. This total IPv4 size is 32 bit, means binary number. This one is divided into four parts. Four parts. 32 by 4 is 8 bits. Each part is 8 bits. These 8-bit part is 8 bit. We have 8 bit and 8-bit number is there. Is separated by dot. Okay, dot dot. 8-bit, because it's 8-bit, we call this 8-bit as a octet. Octet. Okay, the first one is this. This is called a first octet. Second octet. Third octet. Fourth octet. First octet, second octet, third octet, and fourth octet. You know what is the octet size? 8 bit, 2 to the power of 8 means 256. Meaning is it's 0 to 255. Okay, it's not 20 to 256, guys. See, 0, 1, 2, 3, 4. How many numbers are there? 5 numbers are there. Okay, so it's a 5. It is a 5, not a 6. Okay, it is a 5. Same way it is 0 to 255 means each octet size is maximum number is 255. Maximum number. Minimum number is 0. So in each octet it can be a 0, 1, 2, 3, 4, 5 up to 255. Each octet maximum size is 255. Each octet size is 0 to 255. Not more than 255. For example, I am writing an IP address 123 342 1 3. It is an invalid IP address. How? Because this is more than 255. I am writing an IP address 1.0.0.1. Valid IP address. Or maybe 1.0. Valid IP address. Means at least IP address it is. This is not. This is wrong IP address. Wrong IP address. Completely wrong. Okay. Some people, for easy to conveyance purpose or easy to understand, easy to remember purpose, they use this kind of things: W, X, Y, Z. W, X, Y, Z. But originally this is called, first one we call it a first octet, second one we call it second octet, third one we call it third octet, fourth one become a fourth octet. Okay. For some people, for their convenience purpose, certain textbooks telling so it's a first octet as a W, second octet as a X, third octet as a Y, Z. Okay, that is also okay. If in case you are learned already like this, no problem, guys. W, X, Y, Z also representing the placement of octets. Okay, first one, second one, third one, and fourth one. Okay, that one only I have written in this one. Okay, this IP address range. If you start an IP address range, the starting IP address. If you start an IP address, the starting IP address is in total IPv4 addresses is 0.0.0.0. And we should write like this 0.0.0.1. 0.0.0.2. You have to keep writing. Once you reach 254 and 255, means 0.0.0. What is this? From here to here, see, 1 is added here. Guys, after 99, we got 100. After 199, 200. After 999, 1000. Right? Nothing is changes. 1 is added, thing is different. So this is the highest number is in the octet is 255, and the next number is become 0, and 1 is added here. If it is 1.255, then it become 2.20. Okay, understand this part?
Yes, sir.
Yes, sir.
Yes. Yes, sir.
For example, this is become 255.255 0.0. What it is become? 1.00 again, 1.0.1. It continuously goes. Okay. The last IP address is 255, 255, 255. So here can see 0.0.0, 0.0.1, 0.0.2. So once it is reaches here, again it is 1.0, 1.1, 1.2, 1.255, then it's become 2.0. Like this, it continuously go on, and then it is 0.0.255. The next one is 1.0.0, 1.0.0.1. If you reach 1.0, 0.1.255.255, it's 2.0. It reaches here, then it is become 1 here. Okay, it continuously go like this only, and finally we reaches this one. This is our total IP addresses. If you write from this one to this one, each IP address you write on a paper and you count it, so you will get this number. These many IP addresses we will get it. Okay. Yeah. Small points, guys. This one also I will give you one or two additional things. Not IPv6 also I will give. Okay. I told about IPv4 and I will tell about few points in IPv6. Then we'll continue IPv4 again. Guys, IPv6 128 bit. Okay, 128 bit. IPv6 represented in hexa number. You know, hexa number, one digit of hexa number represent 4 bits. Either you write 0 or 1, 2, 9, A, and then C, D, E, F. F. All F is binary like this. 0 is represent like this. A represent like this. 9 represent like this. Okay. So it is highest binary bit is 4 bit number. So one hexadecimal represent 4 binary bits. So you divide this one with the 4, means you got 32 hexa numbers. So total IPv6 represented by 32 hexa numbers. Okay, these hexa numbers, totally 32 hexa numbers are there. If you count these numbers, 32 hexa numbers. Okay, 4 hexa numbers, 4 hexa numbers called as a block. One block represent 4 hexa numbers. One block represents 4 hexa numbers. Means divided by 4 means 8. So we have a 8 blocks. We have a 8 blocks. So how it is? First block colon, second block colon, third block colon, fourth block colon, fifth block colon, sixth block colon, seventh block colon, eighth block colon. No. After eighth, no colons. Okay. So that's why I'm writing like this. Number colon. So it is divided by colons only. So this is what I'm trying to say IPv6, but there is a few points in IPv6, guys. Okay, like link local IP address, global IP address, global unicast IP address, link local unicast IP address kind of stuff, multicast address, private IP addresses in IPv6 is there. Their range is also there. Link local means FE80. When you see any IP address with FE80 starting, it is a link local. It is PC generated that IP address, not given by manually or automatically. PC assign itself. In IPv4, we have to assign an IP address. In IPv6, system assigned that IP address to NIC. Okay. Next, global unicast. These two are important, guys. That is represent in a 001 by 3. Actually, it is like this. 200 colon is there, na? So that kind of remaining XX kind of stuff. Starting one is 20000, and yeah, this is the range. When you see any IP address with the starting octet like this, from 2000 to 3FFF, it is a global unicast address. Global unicast address. And of course, there is a loopback and a local host address is there. So that was also I will tell. Okay. So guys, up to here. Okay.
Yes, sir.
So
Yes, sir.
today we'll finish up to this part. Okay. Then tomorrow remaining part I will tell. Remaining part is network portion, host portion, subnet mask. Okay. What is how to assign an IP address is also given. Pictures are there. That is I will tell. And anything left over to tomorrow Saturday, right? Yeah. Tomorrow no classes. Okay. Monday I will tell.
Okay, sir.
Okay. So now
Excuse
we
me,
will
sir.
finish this. Yeah. Tell me.
Sir, like I joined the class a little late, sir. Can you mark me? Then
What's your name?
Miss Gyan.
Jan Prakash. I call your name at least 3-4 times.
Sorry,
At
sir. Like
least no problem. No problem. Better to tell any time because of
no,
if names are not there, attendance you miss, your names will be removed. I think Prakash sir removed some names today. Okay. Good.
Pragati
Okay.
Gauri present.
Which one?
Pragati Gauri.
Pragati. 1 second. Yeah, present, no? Already.
Yes, sir.
Samantha came. Vedant, Vaibhav, Samantha, and Sai Sandeep. These four members are missing. Okay, guys, see it is. And again, we'll back to the IPv4. Okay, IPv4 is 4 octets: first octet, second octet, third octet, fourth octet. Each octet size is maximum of 255, from 0 to 255. And this is a range of IP addresses, means IP address start with 0.0.0 and it will goes up to maximum of 255.255.255. This entire IP addresses are divided into the five classes. Five classes. Okay. So we'll discuss why it is divided. So, but how it is divided? Divided based on the first octet of IP address. First octet of IP address only. Okay. Based on the first octet means the W portion of IP address, we can recognize which class of IP address. We take an IP address. If you see the first octet of an IP address, we can recognize what class of IP address it is. Of course, based on the class, there is certain properties. Okay, based on first octet. Okay, the class A, the starting one is 0. If you write a 0 into the binary format, this is how we can write a 0 into binary format. The first octet 0 is 0. Okay, like this. And what is the range is first one, right? The first bit they will keep and remaining become ones. They invert the entire remaining thing into ones. Okay, so then the range is from 0 to 127. 0 to 127. It is 1 to 126 in certain textbooks. There is a reason. I will tell that one anyway. And class B. So what is the next number of this binary is this one, 128. So it is the second one. So first two bits are kept like that only. Remaining become all are ones. 128 to 191. And class C, 192 to 223. Class D, 224 to 239. Class E is 240 to 255. The class E is R&D purpose reserved. We don't use in our network communication. Even if you try to assign class E IP address, your adapter don't accept. Your adapter don't accept. Okay. So class E is a reserved IP address and it is some R&D purpose or something it is there. We don't use it anyway. Class D is a multicasting IP address. We can't assign to any device. These multicast addresses are used by some protocols to communicate to the multiple devices. For example, like a WDS type, Windows deployment service, like I can install operating system in 10 systems at a time through network. There, class D is useful. Okay, there's so many reasons. Class A, Class B, Class C is a unicast IP addresses we can assign to the devices. We can assign Class A, Class B, Class C IP addresses to the devices, unicast IP addresses. Okay, and but there is some IP addresses we can't assign to the devices, guys. That is also you have to keep in mind. 0.0.0 unreserved are used by service like a DHCP client and default routing. 0.0.0 is a reserved IP address which is used by certain services like DHCP client services. In routers, default routing services, they use it. It represent yellow all or deny all kind of stuff representations. It will do it. but we cannot assign to the devices like laptops or mobile phones, desktops. You can't able to assign it. Not even only 0.0.0. Also, we cannot assign entire zero series. Entire zero series we cannot able to assign. Next, 127.0.0.1 is a reserved local or a loopback address from a same device within the system testing. I will explain that one, guys. Look at here. Okay. For example, I have a service in this PC. For example, I install a Oracle database in my PC for my practice. In my laptop, I have a Oracle database application. And this is having an IP address. For example, my laptop having an IP address is 10.0.0.11. Okay. And I have a client application in this PC only. SQL plus is my application. Now, from my client to server, I want to access. Where is the server application? In the same PC. Where is the client application? In the same PC only. So what I use 127.0.0.1. Directly I can use it. So I don't require this IP address. Okay, directly I can. So every device, for example, this is some web server. Web server application is installed, and this is the web client, like a web browser client application. This is server application. I want to access from this client to server. I can use this point. Even though this device having an IP address like this. For example, BC name is B. So guys, this is an IP address called loopback or localhost IP address. This is my CPC. I have this SQL plus client application. Application is there. Want to connect to APC. This server it want to connect. So what IP address it has to use? 10.0.0.11. Okay. So because of same PC, same device access, I'm using local host address. And because of maxing from other side means I have to use the IP address. For example, I want to access this website from here. I want to access this particular website from here. So I have to use 10.0.0.12. Then request go to this server. If I use 127, it search in the same machine. Okay, that is the importance of this one, guys. It is also reserved. We can't assign to any device from same device access within the system or for self-testing purpose. Self-testing purpose. And also we cannot use 127 series. Okay. Okay, guys, up to here.
Yes, sir.
Not only those things, guys, this particular type of IP address also we can't assign. 169.254 dot something dot something. Because of this entire IP address range is called a APIPA range, automatic private IP address range. What is this IP address? System assigns. We cannot assign, but system will assign this IP address to your adapter. In case of you are not getting an IP address from DHCP server. Either you should configure IP address manually or you should get an IP address from DHCP server. So you didn't configure manually. Okay, you didn't configure manually, and you don't have a DHCP or you are not getting IP from DHCP server. So what happens? System will assign an IP address to your in this range. Okay, that's it, guys. This is one. So check this information. Okay, so try to recognize which one is which one. So tomorrow I will ask. I'll give you an IP address. Identify what class of IP address it is. Okay. Meet you
Okay, sir.
tomorrow, guys.
Okay, sir.
Okay, any changes? If tomorrow any changes, tomorrow class is there. Even Saturday class is there. But if any changes are there, means if I am not taking class or kind of stuff, any changes, I will inform. Same time, 10:30.
Okay, sir. Thank you, sir.
Okay. Thank you, guys.
Okay, sir. Thank you.
Thank you,
Thank you,
sir.
sir.
Thank you.